Let's see what we can do about reducing this rational expression. We know how to do this. We're going to factor as much as we can and then cancel any common factors. So out of this numerator, notice that we've got nothing in common with the numbers, but we've got 3 x's here, 2 x's here, and 1 x here. So we can at least factor out an x, and that's going to leave us a 5x squared plus 11x plus 2. And then in the denominator, notice we've got no common constants, but we have 3 x's, 2 x's, and 1 x. So again, we've got 1 x in common. So let's take that x out. And if we do that, we're left with 5x squared minus 4x minus 1. Now let's rewrite this expression here with these trinomials factored, if in fact they do factor. So let's see what we've got. X times, let's write our parentheses, anticipating we can factor that numerator. 5 is prime, so we'll have to go with 5x and x. And then this 2, well, that's prime. There's only one way to get that, a 2 and a 1. And I think if I put the 2 over here, that's going to give me a 10, and then a 1, I can get an 11 out of that. So we'll go with a 2 there, a 1 here. This 2 is positive, so these two numbers will have the same sign, which is that middle plus sign. Now in the denominator, we're going to have an x. Let's write our parentheses here, and then we're going to have, again, we'll have that 5x and an x. And now we've got a 1 here, and the only way we can get a 1 is a 1 and a 1. So it's going to have to be a 1 and a 1. This is negative, so they have opposite signs. And I'm going to put that middle negative sign with the bigger of the two products. And the way I wrote mine, the outer product is 5x. The inner product is only x. So I'll put that minus sign with the bigger product. So I'll put it over here, I'll get negative 5x plus x is negative 4x. And now I can see some common factors, right? We've got the x's, those will go out. We got the 5x plus 1 here, that'll go out with that one. So let's cancel those. We're actually dividing them out, but we'll say we're canceling an inefficiency. So the x's will go, the 5x plus 1's will go, and doing that, we will be left with x plus 2 over x minus 1. And so what we're saying here is that we can take this set of computing instructions, replace it with this set, much more compact, much more efficient. And we can do that as long as x is not equal to, now, just to find out what we're going to put here, just take it back one step. What can x not be? It can't be 0, it can't be negative 1 over 5, and it can't be a 1. So we can't get a 0, we can't use a 0, we can't use negative 1/5, and we can't use a 1. In number 73, looks like we're going to use factoring by grouping, right? I've got 4 terms, and nothing is common all the way through. I've got a WW, no W's. I got 5 and 5, but 5's not over here. So we've got 4 terms, nothing common all the way through. This alerts us to factoring by grouping. So to do this, let's group together these first 2 terms, and what's common here is a W, and in the second 2, what's common is a negative 4. Remember what we do here is we find out what's common and we take out that factor and use the first sign in the group. In this group here, the first term is negative, so we'll take out a negative 4. Now in the bottom, these 2 terms are identical to the top, so we'll take out a positive W. Right, the first term in this group is positive. And in the second group, we've got a 5 common, and the first term in that group is positive. So we're going to remove a positive 5. Right, the first term in this group is positive. So let's remove those and see what we have. So we'll take out that W, and what's left is, right now, if we're removing a W from here, we're left at that Y and the 3. So we're left with a y plus 3, and then take out a minus 4. And if we take out the minus 4, now we had negative 4y. If we remove the minus 4, or the negative 4, we're left with a y. Now let's see if we can get it a y. And then, what do we put over here? Well, negative 4 times what is negative 12? So a little division, negative 12 divided by negative 4 gives us plus 3, and what do you know? these two factors just happen to match. Now, let's do the denominator. So take out that w, it will be w, and we'll get y plus 3. And then we'll take out the plus 5. And if we take out a plus 5 here, we're going to be left with y plus 3. And now what we have is this y plus 3 is common here. So let's take that out. So we'll take out the y plus 3. And if we take that out, we're left with this w minus 4. Change the color all of a sudden here. And then we'll take out the y plus 3 in the denominator. And what we're left with here then is w plus 5. So we're left with w plus 5. And now we can see the inefficiency. Let's cancel those y plus 3's. And doing so, we are left with w minus 4 over w plus 5. Now, in this problem, number 101, notice that this is prime, the denominator is prime. We can't do any factoring, so there's nothing to cancel. Now, so we're going to say now that this expression cannot be simplified, so this is our result here. And one thing we do not want to do, okay, so let's put it in red here. Do not cancel the x's and the 6's. All right, so we're not going to do this. If we rewrite this to look like this, x minus 6 over x plus 6, we are not going to do this. We can't cancel the x's. We can't cancel the 6's because we're canceling common terms, not common factors. So remember, one way to remember this is if you can't factor, you can't cancel. If you cannot factor, you cannot cancel. And up here, I cannot factor, so I cannot cancel. Now in number 111, we're given that the area of this rectangle is x to the 4th plus 12x squared plus 35. And what we're supposed to do is find the width, all right? So what are we going to have here for the width? So here's a fact that we know from geometry. The area of a rectangle is the length times the width. So we know that the length times the width is this x plus 4 plus 12x squared plus 35. And in this case, we're given the length, right? The length is x squared plus 7. So we know we've got this x squared plus 7 times the width. That's equal to x to the 4th plus 12x squared plus 35. And now it looks like we've got this trinomial here partially factored. So let's just get this w by completing the factored form here. So how about this? We'll get x squared plus 7 times what is going to give us x to the 4th plus 12x squared plus 35. We've already got the x to the 4th, right? We know we're going to put an x squared over here. X squared times x squared is the x to the 4th. So we're going to put an x to the 4th here. And now 7 times what is going to give us 35? Well, that's got to be a 5. So we'll put a 5 here. And we know that the 35 is positive. It's a positive. So these two numbers have to have the same sign. And that's going to be that middle plus sign. All right, so there's the width right there. So the width is x to the 4th plus 5.